Hello everyone, hope all of you are fine. My dear students, today I came up with a very important topic, that is aromatic compound and how to identify an aromatic compounds, right? So let's start. Now, what are aromatics? See, the name only state aromatic. The aromatic, it came from the word aroma. Now, what does this aroma mean? Aroma means sweet smell, right, or pleasant smelling compound. So the question is that, are all the compound, whichever may be the compound or whatever may be their source, are all compound are aromatic, which are having sweet smell or pleasant smell? That is a question. No. The answer is no. Why? Because in order to be aromatic compound, it need to follow certain characteristics, it need to have certain criteria. Okay, so we will understand what are those criteria and how to identify the aromatic compounds. Okay, so watch the video till the end in order to understand or have a clear concept about it. Okay, so what are the characteristics of an aromatic compound? The first thing is that it need to be cyclic. Yes, so aromatic compound need to be cyclic. Okay, now if I give a compound like this, say I have taken a compound like this, and on the other way I have taken a compound say like this. Okay, so this type of compound can never be aromatic. By looking at only you can say that they are non-aromatic. They are non-aromatic. Okay, so they can never be aromatic. In order to be aromatic, they need to be cyclic. Okay, that is the first criteria. Okay, so the second criteria is that they need to be planar. They need to be planar or flat, you can also say. Okay, they need to be planar or flat, mean two-dimensional. Clear? They will never show three-dimensional, but they are two-dimensional. Okay, so they need to be planar. Now the third important point is there. You can already see that I have given some double bonds. Yes, so this double bonds resembles what? Pi electrons. Okay, so they must have pi electrons, but that too also in conjugation. Now what is that? What does it mean? Okay, here you can see that this compound, this is an aromatic compound. Okay, I have drawn the structure of benzene here. This is an aromatic compound. Okay, conjugation means alternate. See, this is pi electrons or pi bond. Okay, and here sigma, pi, sigma, pi, sigma. This is known as conjugation. Conjugation means in alternate position. Okay, so in this case you can see here that the pi electrons are in conjugation. It is not like that pi, sigma. This is not a conjugation. You cannot say that this is conjugation. In order to be conjugation, it needs to be in alternates, pi, sigma, pi. Okay, so what are pi bond? Pi bond are formed by the double bonds, right? Okay, and the electrons which are participating here, they are the pi electrons, right? So you also already in the chemical bonding chapter you have learned about which are sigma electrons and pi electrons. Okay, but then also let me tell you, so these are the pi electrons, 1, 2, 3, 4, 5, 6. So in this case we are having 6 pi electrons. Okay, and they are in conjugation. Conjugation means one after the another. Clear all of you? Okay, the fourth important point is that, okay, they resist what? Addition reaction and oxidation. Okay, so these type of compound, they do not go for addition reaction, which we have normally seen in case of multiple bond. For example, say alkene, alkyne, we have seen direct addition reaction they go through, right? and they can be easily oxidized also. But in aromatic compound, if the compound is aromatic, they will resist addition reaction. They will not go through addition reaction normally, or oxidation also normally, like the unsaturated compound. They will not behave only like an unsaturated compound rather. But instead of that, they will show what? Substitution reaction. Substitution reaction. Okay. Now you know very well that substitution reaction is a property for a saturated compound. But here aromatic compound with pi electrons with double bond showing substitution reaction. Okay, so this is very interesting, right? So they will resist addition reaction or oxidation, and they will show or undergo through the substitution reaction. Clear all of you? Now the fifth point, which is most important, that is 4n plus 2 pi electrons. Yes, this is also known as Huckel'S rule. This rule is also known as Huckel'S rule. Okay, this is known as Huckel'S rule. Now, it says that if any compound is aromatic compound, then it must have this number of pi electrons. It must have this number of pi electrons. Now you can put the value of n. Say if I put the value of n 0, okay, then number of pi electrons will become how much? You say 4 into 0 plus 2, which means I will have 2 pi electron. If I say put n is equal to 1, then the number of pi electrons will be 4 into 1 plus 2, that is 6 pi electron. If I put the value of n is equal to 3, then 4 into 3, 12 plus 2, 4, yes, 4 into 2. Okay, 2, 1 I have put, okay. So let us take 2 first. So 4 into 2 plus 2, how much? 10 pi electrons. So like that it goes on. Okay, if you take n is equal to 3, then how many pi electrons you will get? Calculate. 4 into 3 plus 2, 4 into 3, 12, 12 plus 2 is 14. 14 pi electrons will get. So if this figure comes, okay, if this number of pi electrons you are getting in a cyclic compound, they are sure to be an aromatic compound. Clear all of you? Okay, so this is very important, Huckel'S rule. Okay, so here you see how many number of pi electrons are here. Let's see, match. 1, 2, 3, 4, 5 and 6. So 6 pi electrons are here. Is the number 6 here? Yes, 6 is here. So which means benzene, this is the structure of benzene. Benzene is an aromatic compound. Yes. Okay, understood all of you? So in order to be an aromatic compound, these are the characteristics or the criteria which any compound or which an compound must have in order to be an aromatic compound. Okay, so always remember, it can have pleasant smell, but it will be an aromatic? No, it's not necessary. It has to show these properties, then only it will be an aromatic compound. Clear all of you? Okay. Now let's move on to the types of aromatic compound. Okay. Now normally there are two types of aromatic compounds. Just a minute. Okay. So what are the types? One is benzene oids and another is non-benzene oids. So there are two types of aromatic compound or two class you can say. One is benzenoids, mean which are derivatives of benzene, and another are non-benzenoids which neither belong to the benzene family nor they do so any relation with the benzene. Okay, so benzenoids are those class of family, mean they are benzene, they belong to the benzene family. Okay, so they are known as what? Benzenoids. Clear all of you? And non-benzenoids, they will show all the properties or all the characteristics of an aromatic compound, but they do not have benzene ring in them. So we will discuss one by one. So let's start with the benzenoid first. Okay, so I'll start with the benzenoid first. So let me erase this part and quickly discuss benzenoids. Benzenoids. Okay. Now benzenoids, obviously they have benzene. So let us understand 1, 2, 3, 4, 5 and 6. Okay. So 6 carbon is there, and in alternate position you will give double bond. Okay. In alternate position you will give double bond. So here it is a pi electron, sigma, pi, sigma, pi, sigma. Okay. So it is showing, or it is showing conjugation also. You can see pi, sigma, pi, sigma, pi, sigma, alternate position. So this is conjugation. Okay, and this is planar also, flat. This is flat. Okay, two-dimensional. Clear? So let us go now. Finally, let us check how many number of pi electrons are there. 1, 2, 3, 4, 5, 6. So 6 pi electrons, which mean this is aromatic. Okay, let's go for another. Belong to benzene family only. Okay, that is naphthalene. Yes, we all have seen naphthalene, pleasant odor. Okay, this is naphthalene. Clear? Now you can see here 2 benzene ring is attached here, right? So which mean, now let me tell you one thing. Most of us, or I have seen most of the students, they place the double bond anywhere. So sometimes I have seen anywhere they are placing the double bond without noticing that whether it is correct or wrong. Now if you do this thing, you are doing a blunder. You are doing a blunder. You must know where to place the double bond while this type of compound, where you are writing the formula of this type of compound. So it's very easy, just follow the tricks. Okay. So what I will do is that by default I have to, this is the bond line structure, right? So by default you have to think that there are hydrogen. So there are hydrogen. So hydrogen we never saw in the bond line. There are hydrogen, right? So it just take a minute to understand, but this is very important. Now, you know, in one benzene ring, how many hydrogens are there? In one benzene ring, how many hydrogens are there? Yes, 1, 2, 3, 4, 5 and 6 hydrogens are there, right? So 6 hydrogens are there. But do we show them in the bond line structure? No, we never show in bond line structure the hydrogen, right? So, but you see here, look at this carbon, 1, 2. So let us find out. Another thing is very important, that carbon is tetravalent, which means carbon cannot show more than 4 bonds. That is also most important. So keeping these two things in mind, we will first count the number of bonding here. So let's start with this carbon. Okay, 1, 2, 3. Okay, now very interestingly, these two carbon has been joined. They are joined to each other, isn't it? You look at this, these two carbon, they are joined to each other, which means they are substituted. Yes, just now I mentioned that in order to be aromatic, they will go through the substitution reaction. Now these two carbon, they have to lose 1 electron or 1 hydrogen in order to get attached with another carbon, right? So they are substituted here. Got my point? Okay, see, that is the reason I have not given hydrogen over here, because if hydrogen is there, then it cannot link, that carbon cannot make the fifth bond. Okay, if I place that hydrogen over here, so which means this is a substituted. That means that hydrogen has been removed and in that place it has bonded with another benzene ring. Okay, so which means 1, 2, 3, I will place the double bond here. Clear, all of you? Understood? Got the point? Okay, so we'll place the double bond here. Okay, so same for this also. So always start with the substituted carbon. That is the main thing. Yes, so this is the substituted carbon. This is the substituted carbon. So I'll place another double bond over here. Clear? Now count. 1, 2, 3, 4. 1, 2, 3, 4. So these carbon is satisfied. Now let us check one by one. This is another carbon, 1, 2, 3. So which mean one double bond is required here. So I will place a double bond here. Understood? Okay. So 1, 2, 3, 4. Now count for this. 1, 2, 3, 4. Satisfied? Now for this 1, 2, 3. Another bond is required. So I will place a double bond over here similarly. Okay. Now check. 1, 2, 3, 4. Now for this carbon 1, 2, 3, 4. Mean this side is over. Now let us come to this side. So for this carbon it is 1, 2, 3, 4 already counted. For this carbon 1, 2, 3, 4 done. Well, so for this carbon 1, 2, 3. Yes, here one double bond is required. So I will place a double bond at this point. Now count 1, 2, 3, 4. Now for this carbon also 1, 2. See, look at it. 1, 2, 3, 4. For this carbon also, this is common. This double bond is common, right? So which mean all the pi electrons I have placed correctly in their correct position. So whenever you start placing the double bond, always start with the substituted carbon. Okay, always start with the substituted carbon. So you will never do the mistake. Now in book you will find that this hydrogen will not be given. And the structure will look like this, and you will get confused. You may think that where to place this double bond and how this double bond has been placed, but I have taught you, so you will never do mistake again from now onwards. Clear all of you? Okay, so this is your naphthalene. This is your naphthalene. Okay, now is the naphthalene, is it a aromatic compound? Yes, it is an aromatic compound because it is a cyclic. Okay, now go by the sigma pi conjugation. Okay, let me start from here. Sigma pi, sigma pi, sigma pi, sigma pi, sigma pi. Very good. And sigma is also here. Okay, so sigma pi, sigma pi, sigma pi conjugation is going on like that. Okay, so it is well conjugated. Clear? Now let's count the number of pi electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we are having 10 pi electron. If that 10, number 10 was there in 4n plus pi, 4n plus 2, let's see, 4n plus 2. If I put 4 into 2 plus 2, isn't it coming 10? So yes, it is obviously an aromatic compound. Clear all of you? Getting idea? Okay. So let us do one more to understand much more clearly. 1, 2, 3, 4, 5, 6. Okay. Join this. Okay, now quickly pause the video. This is known as anthracene. Anthracene. Okay, so this is known as anthracene. Now in anthracene, first quickly pause the video immediately over here and try to place the double bond as I taught you. Okay, done. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so just count the number of carbon. Okay, and try to place the double bond. So where to place the double bond? Obviously I will start from the substituted carbon. So this is the substituted carbon. So I will place one double bond here and another double bond here. Okay, yes, then in the alternate position you will give another double bond. That's it, that's simple. So here leaving one carbon, again another double bond, automatically it goes on like that. Now here in this case what will happen? This carbon 1, 2, 3, 4 bond is already given. For this carbon 1, 2, 3, oh, where is the third one? Yes, it is a hydrogen, which is invisible hydrogen. Invisible, not visible. Okay, so you have to imagine that there is a hydrogen. Okay, so 1, 2, 3, 4. Clear all of you? So now count for this. 1, 2, 3, 4. Okay, so it goes on like that, So this is also another substituted carbon. You can see these are also substituted carbon because of one more chain. So I'll place one more double bond here also. It goes on like that. Okay. Now for count for this. This carbon 1 2 3 4 1 2 3 4. Now for this, yes, that invisible hydrogen, yes, it is here. Okay. So 1 2 3 4 bond is here, and then just leave one position and give the double bond. That's it. It's simple. Once you learn, just a little bit of practice is required, and it will be very simple, and you will never do mistake in placing the double bond. I assure you. If you follow this string, you will never do any mistake in placing the double bonds. Okay, so that's it. This is the structure of the anthracene. Now, is it a aromatic or a non-aromatic compound? Let's see. Okay, so how many number of pi electrons are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Yes, 14 pi electron mean in 4n plus 2 pi 14 comes, which means it is following the Huckel rule. It is a cyclic compound also, you can see here. Now is it showing conjugation? That is another important. Let's see. Pi sigma pi sigma pi sigma pi sigma pi sigma pi sigma. Okay, here one more sigma pi sigma sigma. Okay, so it is also showing conjugation system. Okay, sigma pi conjugation is going on. Okay, so anthracene is also a what? Aromatic compound. But only conjugation is enough to identify. Let's take another example. Okay, that if it is placed in conjugated system also, so never do this mistake, always check. Okay, and obviously go by this rule. So I am giving you one example where you will see this. Let's see, 1 2 3 4 5 6 7 and then 8. Okay, so let me place double bond in alternate position. Okay, can you guess the name of this, my dear students? Can you guess the name of this? Yes, it is a cyclic compound. So cyclo, how many carbon are there? 1 2 3 4 5 6 7 8. Cyclo octa tetra in. Cyclo octa tetraene, right? So you can see here that pi, this is a cyclic compound. Okay, pi sigma pi sigma pi sigma pi sigma conjugation is also there. Then is it an aromatic compound? It's looking like an aromatic compound. Let's find out. So how many number of pi electron? 1 2 3 4 5 6 7 8. 8 pi electron is there. 8 pi electron is there. So in 4n plus 2 rule, 8 is not there. So it is non-aromatic. Understood? So this is although it satisfied the other condition, but since it is not following the Huckel's rule, so this is non-aromatic compound. So these are benzenoids. So I hope it is clear now. Okay, I have taught you what are benzenoids, and also in the same time I also taught you where to place the bond. Clear all of you? So let us discuss the non-benzenoids part. Okay. Now there are certain compounds. Okay, there are certain compounds which do not have, they don't have a benzene ring, but then also they behave as, or they are aromatic compound. Okay. So we are going to discuss about excuse me, such type of compound. Let's start with this simple. Can you guess the name of this compound? Anyone? Yes, can you guess the name of this compound? Anyone? Write it. Okay, so Pyrol. Let me tell you, Pyrol is the name. Anyone? Okay, so is it a aromatic or a non-aromatic? Yes. If I say it is an aromatic, prove it, right? Here you see this is a cyclic compound. First condition is satisfied. It is planar. This is planar only. Okay, it is two-dimensional flat in shape. Okay. Conjugation. Yes. How to understand conjugation, sir? Okay, pi, sigma, pi. Now what about this? Sigma or pi? Now here you see pi, sigma, pi and count this lone pair also. Yes. So not only that pi, sigma, pi come in conjugation. Sigma, pi, sigma also come in conjugation. It can also come like that pi, lone pair, pi conjugation, sigma, lone pair, sigma. It can also have a conjugation. Okay. So you can see here after this. Okay, after this there is lone pair, right? So pi, lone pair and pi. You can see pi, lone pair and then again pi. So this shows the conjugation. Yes. So the fourth condition is also satisfied. Finally the Huckel'S rule. Yes. How many pi electrons are there? How many pi electrons are there? Okay. Let me tell you one thing. If this lone pair, you can see that this lone pair is inside the ring. Okay, it is inside the ring. In case of pyrrole, it is inside the ring. Okay, so which means you have to consider this also in the pi electron only. Understood all of you? Yes, this is very important to note that when this lone pair is inside the ring, it is also getting delocalized. Understood? So this is also acting like a pi electron only. So how many pi electrons are there? Now finally count 1, 2, 3, 4, 5 and 6. 6 pi electrons are there, which means it's following the Huckel'S rule and it is what? It is a aromatic compound. Clear all of you? But it is a non-benzenoids. You see there is, it is not, no benzene is here, no benzene ring is here. But then also it is behaving or it is an aromatic compound. Clear all of you? Clear? Okay. So let's take one more example. Why one more? Let us discuss few more. Yes, your exams are nearing. Okay, I have replaced it with oxygen. Then the name also changes to furan. Furan. Okay. Again, same case. Pi, sigma, pi. There is no benzene ring, so non-benzenoids. Okay. And these two also you have to count in the what? In the pi electrons. So 1, 2, 3, 4, 5, 6. So conjugation is also there. Okay, and 6 pi electron is also there. So furan is also a aromatic compound. Clear? Getting the idea, my dear students? Let me replace this with sulfur. Okay, the name will change. If I replace it with sulfur, then its name will be thiopine. It is thiopine. Now in case of thiopine also you have to follow the same rule. Pi, sigma, pi and this lone pair. Okay. So how many pi electrons? 1, 2, 3, 4, 5, 6. So 6 pi electrons are there and it is also in conjugation. So thiopine also aromatic compound. So thiopine is also an aromatic compound. Clear? Getting an idea? So these are non-benzenoids. So see, they are not benzene derivatives, but they are aromatic compounds. Excuse me. Okay, let me discuss one more. 1, 2, 3, 4. Excuse me. Okay, so try this one out. Okay, I placed it here. 1, 2, 3. Okay, So try this one out. Quickly try this one out. Okay, so in this case the lone pair is outside. Okay, and what is the name of this? This is pyridine. This is pyridine. Okay, now is it an aromatic compound or non-aromatic compound? Is it an aromatic compound or non-aromatic compound? Yes. Is it a cyclic? Yes, it is a cyclic. Pi sigma pi sigma pi. Then here what to do? Okay, pi sigma. Is it coming pi pi like that? Is it an aromatic compound? So yes, it is an aromatic compound. Why it is an aromatic compound? Because here you can see one sigma bond is also here. Clear? One sigma bond is also here. Okay. Now, interestingly, this lone pair this time it is outside. This lone pair this time it is outside. So you cannot consider it as pi electron. Okay, so in pyridine, in case of pyridine, how many number of pi electron? 1, 2, 3, 4, 5, 6. So 6 pi electron which satisfy the Huckel'S rule, and all the conditions are also satisfied. So this is what? This is what? This is aromatic compound and non-benzenoids. Clear all of you? Okay. Now just let me take two more examples which often can be asked in the competitive level. Okay, just to make you aware that there are certain ions also, cyclic ions, they can also consider, you can also consider them as, or they show aromatic or aromaticity. Okay, for example, cyclopropene cation. We have cyclopropene cation. 1, 2, 3 and cation. This is known as cyclopropene cation. Okay, this is cyclopropene cation. Now in this case you see sigma pi sigma conjugation is there, right? Sigma pi sigma conjugation is there. Is it containing any benzene ring? No. It does not have any benzene ring, but then also it is an aromatic. Why? Count the number of pi electron. This is a cyclic compound, is well conjugated, right? Now, number of pi electrons. 4n plus 2. 4 into 0 plus 2. 2 pi. Are we getting 2 pi electron? Yes, it is having 2 pi electrons, which means this is an aromatic compound. So it is always not so that conjugation will always going to help you out, but you need to also check with the number of pi electrons as well. Understood? Getting the idea? Okay, so if you face this type of question, I hope you can understand that which is aromatic and which is non-aromatic compound. Clear all of you, my dear students? So in these video lectures I have tried, okay, without making the video much lengthy, I have tried to make you understand what are aromatic compounds, how to identify aromatic compounds, the types of aromatic compounds, and obviously where to place that bond while writing the aromatic compounds. So hope the video was helpful. So thank you for watching. Stay healthy, stay safe. Bye bye. Take care.